Hello everyone and welcome to yet another recreation programming session with Mr. Azozin. This is an offline session, so there is no chat or anything, just me vibing. I've been doing JSON plumbing in Jai, and I encountered some opportunity to do a little bit of open source development. So Jai doesn't have a built-in JSON support. Obviously, it's a language created by Jonathan Blow. Obviously, such language wouldn't have a JSON support. But luckily, there is a third-party dependencies that add a JSON parsing support to Jai. One of them is JSON, created by one of the main developers of Jai, by the way, Rafael Luba. And I'm really grateful for him actually providing this implementation. It's great. It's absolutely great. I love it. So let's take a look at it. I'm going to clone it. And the way modules, additional modules in Jai work is that in your project, you have to create a modules folder, right? So here's a modules folder, and you put a module folders in there, right? So you put all of your modules there. And now in your project, you can just go ahead and import this specific dependency. So JSON, I'm going to recompile super quick, main.jai, and it works. So let's define maybe some sort of a JSON string, like so. And let's maybe have an object with two fields, foo, which is going to be 69, and something like bar, which is going to be, let's say, 420. So then what you can do, you can, just like in Go, you can define a structure. I don't know how to call this structure. Let's say test structure, right, is going to have two fields. First one is a foo, which is an integer, and bar, which is an integer. So, and as far as I know, let's go into maybe readme, and there's an example. You can parse a string. So there's this function, very simple function. You feed your string in there, and you also specify the type which you want to parse, right? So types in Jai, they can be passed as the parameters. So, and then you get an actual JSON, but as far as I know, the first argument is actually whether it succeeded or not, right? So if it didn't succeed, so let's actually just return out of the function. If we did succeed, let's go ahead and print whatever we managed to print. So I might as well say equal, like so, and let's compile it and auto run it as well. There we go. So, and we managed to parse it. It is as simple as that, honestly. It is super simple. So, and I was parsing the response from the FFZ extension for Twitch. So it's minified, right? So it's probably not very easy to read. So let me maybe just basically do cut FFZ JSON and feed it into JQ dot. So it will pre-print it. So can we just like not have the colors? Yeah, there we go. So, and essentially, here's the thing. It's an object that has two main fields, a default sets, right? And it's basically an array of integers. And those integers are keys into the object that is located in a different field, right? It's in sort of like a sibling fields. And here's the thing, because of that, this particular object doesn't have any specific structure. Like it doesn't have. The fields that it has depend on the elements in this specific array. Because of that, you can't really define, you know, something like FFZ response, which is going to be a structure. Then you can have default sets, which is going to be where is the compilation? There's going to be an array of integers. You can do that, but then in here, like you can't define sets as any particular structure. It has to be hash table. Jai does have hash tables, right? So it's literally hash table, and you define them like this. Right, so this is a table, and structures in Jai, they act like functions. If they are generic, they can accept parameters. So in here, we can say that the key is going to be a string, and the value is going to be... So essentially, this is one of the emotes. So for those who doesn't know, by the way, FFZ extension, yeah, so this is how you say it. It's an extension for Twitch. It's a browser plugin, which adds additional emotes and stuff like that. So I was just like parsing the responses from its API. All right. And yeah, so that's one of the responses in here. So maybe I'm going to put it in the description. like so. So here it is. And by the way, let me also put the Raphael's JSON Parsing library in the description as well. So in here, you probably have to define FFZ emote, which is going to be a structure, obviously, but these structures, they do have a very specific fields. So what we need in here is probably, yeah, it has emoticons, right? So this specific structure has emoticons, which is an array. So since it's more of like actually FFZ set, right? So it's a FFZ set, and set has emoticons which are excuse me, which are arrays of FFZ emotes, right? Something like that. So that's basically the structure, FFZ emote, which is going to be a structure. And within the FFZ emote, we have ID at least, which is an integer, right? So then name, very important, it's going to be a string. And I guess that's about it. So it also should contain some URLs, but we're not going to parse them, right? So you can omit some of the fields, and the JSON is not going to actually parse them. So in here, so FFZ response consists of sets, which is a table from a string to FFZ set. So that's basically what we can have in here. All right, so I need to read this entire thing into a string. Right, so let's go ahead and do that. So as far as I know, there was a read entire file, and we can do FFZ JSON, and it will return JSON string, or whether it succeeded or not. Right? If it didn't succeed, we're going to return out of this entire thing. Then we're going to feed in that into the JSON parse string, and we're going to say it has to be FFZ response. And in case of a failure, it will log the failure, right? So then we can exit in here. All right, so I'm going to try to compile and run the whole thing, and read entire file is not found. This is because it is located in the module file. There we go. Okay, so it managed to parse the default sets, the IDs of the default sets, but then the table is empty. The hash table is a rather complicated structure, right? So we can take a look at how it looks like it internally. So hash table, and there's a table, here it is, right? So these are all of the compile time parameters of the structure. And internally, it has a lot of things like how many elements, valid elements it has, how many allocated, field, the allocator itself, you can customize the allocators, so the entries, where it stores all of that, there's a lot of things in here. But as you can see, all of them, all of these internal things are 0, right? So nothing was actually added into the table. And this is because Jai literally doesn't support the JSON. JSON literally doesn't support these kind of types in here. It literally doesn't. There is even an issue for that. So it is somewhere down. GitHub, it's so slow, god damn it. Add support for tables. There you go. So table from hash table that we just used is empty when parsing type JSON. It would be great to have a support for loading arbitrary data as a table. I agree with that. So, and I think somebody's volunteered to actually implement that. So if I accept contributions, I may give a try to implement the missing table feature and submit a PR. And it was in February of the last year. So, and I suppose it was never really submitted or implemented, which is a very common thing on GitHub, by the way, and open source in generally. So you kind of feel like you can implement a thing, you commit to that, and then the real life kicks in and it just kind of gets abandoned. And yeah, so the usual thing. I'm not blaming the person who volunteered to not, for not implementing that. That's totally understandable. I did the same many times throughout my programming life. So, and yeah, I decided to maybe give it a try, right, on a session, right, just to see if I can figure it out. So sounds like an interesting exercise, actually. Sounds like an interesting exercise. Sounds good. Sounds good. Sure. Sure. Let's fucking go. So I suppose the first thing you need to do, you need to find like this function, right? So let's just go there. So maybe we can even debug that. I think debugging that could be even more interesting. gf2 main, and yeah, I'm gonna just break at main. If it's breakable, it seems to be breakable though. Well, we don't even have to do that. Jai has a very cool thing actually. So it has breakpoints. And this is a special function that will just issue a breakpoint on your specific platform. So we can just find it, something like that. So depending on the, it's not breakpoints, it's a single one. On different platforms, it is going to just basically do different things. So there's a debug break. I hope it is within the same module. It doesn't seem to be within the same module, so probably have to search it again. It's a runtime support, and in here it works even at compile time. Right, and depending on the platform, PS5, right, so it's a special assembly instruction, right, for different CPUs, it's just like different instructions. On x86-64, it's obviously going to be in 3. And on WASM, there is no such instruction as far as, oh, well, there is, like a WASM debug break. I think it's literally just an external function. Yeah, you have to provide this function in GS if you want to do that. So yeah, that's basically the thing. And usually the debuggers can catch the int3 trap. All right, so let's go ahead and just like recompile the whole thing. So J Linux, but not auto run it. Okay, so a single one, obviously. And it's located in a module debug. And go ahead and do that, and can now just run this entire thing, and it breaks. Well, I mean, it broke inside of this function, unfortunately, which kind of makes sense, honestly, but in any case, so this is where it is. We have to step out of the function, essentially, and we need to step into the JSON parse string. There you go. So it is, I can't see where exactly it is. It is in the file typed J, so that's the file where this entire thing is located. Okay, so kind of weird way to search for a function definition, but I guess it's fine. It's a line 6. It's right there. Parse a JSON string into a given type. All members of type that are not present in JSON are kept in their default values. All fields in a JSON that have no corresponding member in a type are ignored by default, but you can pass ignore unknown false to fail instead. Okay, that's very cool. So, all right, what do we do in here? We are, yeah, so we're checking the content. That's pretty cool. Then we take the type information for the type. So we're taking type information for the type. Then we parse a value. We're taking a context. The result, I'm not really sure what the hell is the result. Right, so we are allocating, okay, so this one is rather interesting. Wait a second. We are allocating the type that you want to parse on a stack, and then we're passing this type as a pointer cast to a pointer to a byte. So we're interpreting that type as just sequence of bytes. I wonder how do we access individual fields and stuff like that. I suppose maybe the type information contains an information about sets of different fields if it is a structure, obviously. That is actually kind of cool. Right, so, and it parses this entire thing, and the result is probably then just simply returned for you. It just simply returned for you. Okay, let's take a look at the parse value. Might as well maybe step in the debugger. Okay, so let's go into that, and it went into memset. Oh, okay, so because it was trying to do some things in here. Okay, so I'm gonna just go myself. So this is a type info, and I suppose there's only one overloading of the parse value. Yeah, okay, so that's great. Okay, so we're trimming white spaces, nothing particularly interesting. So there's an inner function, there is an internal function parse slot. I don't think I want to focus on that function yet. There's another internal function. So yeah, that is very interesting. So remainder, I suppose this is the characters that we're looking at right now. If it's a character n, so this is the bytes that we're currently parsing in JSON. If after all of the trimming and all of that stuff, it starts with n, we assume it is a null. Okay, if it starts with T, it's a true. If it starts with F, it's a false. If it starts with this thing, it is, you know, quotation mark. Yeah, it's a quotation mark. This is an array, and this is the stuff. All right, where can I plug in looking for the type? I suppose the tables are structs, right? So the tables are structs, and this is where we probably have to do that. Okay, that's pretty cool. So this is the thing. So we are here is the value info, but this is just like two pre-allocated variables. Then we parse a slot, right, for a structure. So we explicitly expecting a structure. So that's very interesting. But what if, but we can, but it, for us, it could be either structure or a table. But it looks like it's implemented so it can be only one thing in here. That is fascinating. So that's probably why it was not immediately implemented, because it requires a little bit of extending, because it's a little bit strict like that, right? So because we need to be able to parse object either that or that, either as structs or as tables, but the whole code kind of puts a constraint that it has to be one of the things, right? So that's probably the problem here. I see. Very interesting. So parse a slot, expected type, type info tag. All right. So, and here, if it is a pointer, you do one thing. If it's an enumeration, you do another thing. So it also supports enumerations, which is kind of interesting. So I suppose somewhere here, it has to have struct, right? If type is a pointer, you go inside of it, and type is a struct. So, but it's a, it says prepare slot. I thought it's parsing slot. It's preparing slot. It's just preparing slot for us. I'm not really sure what the hell is slot, but let's go back to where we're doing all of that. Okay, so we prepared slot for the struct. Then we're parsing the object. We're parsing the object, and here is the function that is responsible for parsing an object. And it takes an info, specifically type info struct, right? So it explicitly expects the info struct. Okay, that is very interesting. That is very interesting. So I want to take a look at what is an info struct. So it's a thing that's probably describing the structure, right? So it should be defined somewhere. There we go. So mangle type info struct. Dang. All right. So it inherits type info. Okay, so it has a name, it has a parameters, right? So structures may have parameters if they are generics, and there you go. You have members, some status flags, and non-consensual, non-textual. Okay, so non-textual flag, polymorph source struct. No idea what that is. Oh yeah, so the structs can have initializers. They're like constructors, but you can't generate a code for them. You can't write a code for them. It's generated automatically by the compiler. It's usually for setting the default fields, right? So if you say that a particular field has a default value, hello, so there is a code somewhere that goes through the fields and sets the default values, and that code is generated automatically by the compiler, and it is the initializer, right? So, and I suppose John doesn't allow you to define your own initializer, right? So because people may start abusing it, right? So because in initializers you don't want to have any special logic or anything like that, otherwise you're going to end up with the C++ constructor situation or just generally any OOP constructor situation, right? So because there's usually like a best practice in OOP languages is to put as little logic in a constructor as possible and just initialize the fields. Well, in this language, you can't even put any logic in there anyway, so that is not a problem at all. Anyways, so, and this is probably where it gets all of the necessary information to know what kind of things to expect and stuff like that. So what we can do, maybe, is essentially like a parse object, have another one in here, parse object, which accepts the string that you want to parse and the slot and so on and so forth, right? But in terms of info, I suppose it's going to have like a key. So we can say that the expected type of the table, of the key of the table, has to be always string, because I think in JSON you can't even have anything as a key except the string, right? So because of that, maybe we're gonna have a value type, value info, right? So to follow the convention, it's gonna be like literally type info, probably just a pointer to a type info. So ignore unknown, and I don't know what any of these parameters mean. I literally don't know. So because of that, I suppose I'm going to just copy paste them. And this is the result is going to be literally the same, right? I'm just copy pasting things, right? Because I have no idea what the fuck I'm doing. So I'm going to assert false, and this is going to be in to do, not implemented yet. So I'm currently overloading the whole thing. But maybe I shouldn't. Maybe I should explicitly say as a table, at least for now, right? At least for now. So parse as table. Okay, and then here, so maybe I'm gonna start like just copy pasting chunks of this function and just see how I can adapt things. So first of all, we're asserting that the string starts with the curly braces, otherwise this is not an object. Makes sense. Okay, so then we advance the remainder, we advance the string, and we also strip in the white spaces and stuff like that. So that's another thing that we'll probably need in here. That's very cool. So if we ended up with closing brackets, so we're kind of done with all of this, right? So we're definitely done with all of this. So there's a note here, speed. Build this table every time is pretty silly. Building this table. Oh, look at that. There's already table. So, but it's for the offsets within the struct, right? So it's kind of funny that the library uses the hash tables from the library of Jai, but it doesn't support the tables themselves. So I think it's kind of funny. But in any case, so it basically builds a table of offsets for the specific type, right? So it initializes, by the way, as far as I know, you don't have to initialize the table anymore. So like some time ago, I think John made it so just zero initialized table is a valid table. So then you populate the members and stuff like that. We don't really need to do any of that stuff because the tables just will accept any field, right? So here it is needed to actually know which fields to ignore and which fields to include into the thing. So we don't have to do that. So we literally don't have to do that. One thing we can do maybe is to just initialize the result table like by itself, right? So it's going to be table string, but I mean, then we'll have to construct it somehow, so I'm not... Well, yeah, so this is something that we have to put into the slot itself, right? So the slot is the result probably, right, allocated in the memory, and it's a pointer to the bytes that... Yeah, so that's the table, And how to operate with that table, well, we should know it by like having a value info in here. So that's how we should know how to operate with this entire thing. It's gonna be rather interesting. I'm actually not quite sure. So it's probably going to be the table of an array, like with a value of an array of bytes of the size of that value info. Something like that. I feel like that's what it has to be if we want to do it properly. That's going to be interesting. But anyway, yeah, I'm not really sure what to put in here. So it's gonna be interesting. So I'm starting to realize like why it was not immediately implemented, right? So there's all these like questions how you do all of that stuff. But in any case, so we have an infinite loop in here which does the parsing. So do we have anything after that? All right, so we're just like stripping the remainders and checking that this entire thing ends with a curly brace. That is understandable. Not that difficult, honestly. Okay, so we're checking whether the remainder, I'm not quite sure if it's ended, and the first thing is not equal to quotation mark. I'm not really sure what about that. Maybe it's some sort of a assumption that is expected somewhere else in the code. Okay, so I'm parsing a key, right? So a success, and then so I'm just parsing a key, right? So this is something I definitely want to do. I want to parse the key. Cool. And also do defer free, right? So, okay. So then I'm searching for that key in a member table, in a table of the offsets. We don't have to do that. We don't have to do that at all. So member slot info, and this is basically what we're doing here. Look at that. This is actually kind of interesting. So essentially, yeah, we're like slot is the pointer to the bytes that represent the structure. Using the type info, we're locating the offset of the member and we're just setting that member there. There should be mem copy somewhere for that specific thing. There should be mem copy somewhere, but this is probably not what we want to do right now. So it's a member slot. So they are just preparing the member slot. We don't really care about it, at least right now. So we just parse the key and we just hold on to it. We just hold on to the key. Okay, so now we are advancing the parsing further, right? Doing the trimming and stuff like that. And obviously looking for the colon, right? So we parse the key, so then comes the colon. Then we parse a value, and we parse it as just like a generic value. Oh, we parse it as a member slot specifically. That is fascinating. Okay, okay. Though, we, instead of member info, we can use the value info that we have in here. That is cool. So we'll have to prepare the slot as well. So we'll just have to allocate a memory for a value, right? So a memory for a value, and just give it as a member slot and just parse it as usual. That's probably what we'll have to do. So I think I roughly have an idea how to do all of that stuff. Okay, so, and obviously here we are looking for commas and whatnot. All right. And I think that's about it, actually, believe it or not. I do think that's about it, essentially. So, interestingly, this one is going to be a little bit annoying in a sense that the main problem happens. If the table has a value that is stored by a value, so that means the table needs to know the size at runtime, but I feel like table doesn't know the size at runtime. That's the thing. I think the table literally doesn't know the size at runtime. So a hash table, so it's going to be table, yeah, so here it is. So it has entries, yeah, so here is the entry. All of that is known at compile time. The size of the elements is known at compile time, but not at runtime, which means that we can only support something like this, where the value of the table is constant, which is the size of the pointer, which is 64 bits on x86-64, right? And the parsing assumes that specific size of the slot, and it parses everything into that specific slot. So that's literally what we have to do in here. Okay, that's very interesting, actually. That's one limitation I see, right? So I don't really know how to overcome this limitation, and it's a limitation that comes literally from the hash table itself, right? So because the sizes of the keys and the values are compile time parameters, but we need to actually know them at runtime. But maybe we can know them at runtime, can't we? Well, I mean, I need to dynamically construct a table. Yeah, that polymorphs all of the functions, all of the operations on the hash table with a specific size at runtime. I don't think Jai can quite do that unless I don't know something about Jai, and I don't think we even need that. I think just like a workaround of having this as a pointer all the time is good enough, right? So because you're allocating that stuff on a heap anyway, or whatever your current allocator is, because as far as I know, JSON uses the allocator from the context. Okay, so I'm gonna go with that. If there's a better solution, like it shouldn't be that difficult to come up with it. Shouldn't be that difficult to come up with it. So this is a value info and member slot. We need to, yeah, so this is a member info. So I just need to allocate the slot. Let's call this maybe member info, because that's what it effectively is. Right, it's a member info that we're going to be passing like into the parse value, kind of recursively. Is it recursively? No, it's not particularly recursive, but it's a mutual recursive anyway, so who cares? Member slot. So member slot, we need to allocate member slot somehow. But also, I feel like we have to allocate it every time, right? So every time I need to do the parsing, right? So for each individual member, we have to allocate this entire thing. So that begs the question, what is going to be the size? What is going to be the size? So this is just a generic type info. Is there a type info? So I think it's a runtime. Right. I think it's a runtime, not really a runtime. A type info specifically for the pointers. There should be something like that. Let me find it. Let me quickly find it. All right. Emacs being a little bit silly. Okay. So where is the struct in here? Come on. You stop asking questions. All right. So this is a preload, and this is where we have all that. Is there something like a type info point? There you go. This is what I'm talking about, brewskis. So we can explicitly say, right, that this has to be a pointer. It's a type info pointer. So, and then if I need to allocate something, right, so where's the member slot? I take, it's not really member info, it's more, okay, so let's call it value info, right? So this is a value info. And then this is the value info. I take pointer to, and this gives me the type information about the type it points to. So now here, runtime size. Warning, runtime size might be unset for structs at compile time if compilation is not finished. But we're not doing that at compile time, we're doing that at runtime, so that's totally fine. So this is a runtime size, and I want to allocate an array of bytes of this specific size. As far as I know, there is something like a new array, and I say, okay, allocate me an array of that specific size, and this is our slot. This is what we're going to be actually rendering everything. So, and member info, essentially, so I don't even have to provide the type in here. I think I can just do that. And member info is going to be value info. Something weird just happened. My laptop actually went to sleep because I forgot to plug in the charger. It was not charging as I was recording this entire thing. I really apologize for that. Anyway, so the member info is the pointer, right? So this is the what is it pointing to? Right, so this is a type info. Okay, that's pretty cool. And I suppose what I can do is a member info like this, right? So this is that. And then when I'm parsing a value, here is the slot, here is the info. Makes sense. That's it. I think we figured it out. And now what we have to do, we have to put that slot into the table. Right, we have to put that slot into the table, but we have to, oh, this one is interesting because the table is the slot, right? The table is the slot. So that means we have to reinterpret this thing to a pointer to the table, which uses string as a field, and just a pointer as a value, right? So we might as well actually make it like this, so just like a pointer to the void, right? So this is what we're casting it to, and this is our table. As far as I know, it should highlight things, right? If I, yeah, I think this is how we do that. But anyway, so is there any casts in here? Yeah, so this is how we cast things. All right, it's just my Emacs doesn't highlight things well. I think this is probably because I'm like using an old version of Jai mode. Just a second. I think I need to update my configuration super quick. So just let me quickly do that. Yeah. And I'm gonna restart my Emacs super quick, and it's gonna be prob JSON contrib. Let's find module JSON typed. And cast, yeah, it's good. Okay, so there we go. I haven't updated my local .files for quite some time already. So table, as table, there we go. So this is what we need to do. So this is now a pointer to the table, right? And that's the table. After we successfully parsed a slot, what we can do, we can just add to that table the member slot, believe it or not. So that's what we can do, essentially. This should be the implementation of parse object as table. It's just like we need to write the code that makes a decision to call this function depending on what the value is, right? So that's basically what we have to do now. So let me first go to the compilation errors, right? I would just want to see. Obviously, like none of that is going to work yet, but I just want to go through the compilation errors just to see if I didn't make any stupid fucking mistakes, man. No fucking way. Fucking first try. Anyway, didn't even make any like a semicolon or anything. Okay, so just a second. Let me quickly pour some water. Right, so the recording is going to be split in 3 parts, apparently. Oh, what a mess! Oh, what a mess! Anyways, so what we need to do. Let's go and find the place where we specifically looking for the struct. So that's the place, but it's just a fill in members and whatnot. So there was a prepare slot, so that's the function. It prepares the slots, it does some things. Okay, in here, we're looking specifically for objects. Okay. And as you can see, it's just like we are preparing this thing. Slot, what is, like, why do we even check for this thing? It's like in case slot is already set for whatever reason. That is bizarre, a little bit bizarre, not gonna lie. So slot, parse value and slot and type info is already defined, but not quite sure what's up with this condition, right? If slot exists, we're preparing that slot given the information and stuff like that. And prepare a slot as the first parameter. What does it accept? What's the name of the value? Expected type. Expected type, expected type. So that shouldn't be a thing, honestly. Expected type struct. So for them, it actually very much depends on all sorts of things. I would love to maybe print the current type when you're trying to parse an object. So maybe we could, can we do some stuff like, I don't know, maybe we can debug in here. Oh no, we can do breakpoint. Who said we can't do that? We can do that. Where's my main J? It's somewhere there, main J. So here's the breakpoint. And let's try to maybe take this JSON string. Let's actually bring our string back where we had only 2 fields, right? So it's going to be foo, which is going to be 69, and bar, which is also going to be for 20. So that's what we have. This is our JSON string, and what we're going to be parsing, we're going to be parsing test. I said test. Let me quickly get rid of the breakpoint. Super quick. I'm gonna just run auto run. All right, that parses successfully. I'm gonna set the breakpoint. I'm gonna recompile without auto run. So breakpoint is not available because it's a part of the debug. I have to include debugging here. There we go. Cool. And now I should be able to do gf2 main. Let's go. Let's run the whole thing, and we are inside of the parse value, which is installed, but let's actually step out of the break. And I want to inspect the info. Right, so we just have a generally info, and that's the info that we have to parse. So it is, okay, so it's just like a type struct. That's it, right? So it's a type struct. But if I say that this type is a table, what is it going to be? I think it is going to be specifically struct. Yeah. So even if I say that this is a table, right, even if I say this is a table, it is still going to say struct. So I can't say string to integer. Right, string to integer. Can I now do gf2 main? Right, so I'm going to do that. And let's step out of this entire thing. And info, it is a type info, but it's still specifically a struct. All right, that is very interesting. Which also kind of means that, yeah, the prepare slot can detect that the struct is a table. It has a name table, and then it has like keys and stuff like that. It's still, all of that is still detectable, which is great in my opinion, which is actually kind of great. So I want to go into typed. So this is the breakpoint. And in here, one of the things we can do. So how do you recast it, reinterpret cast it? You literally reinterpret cast it like that. Okay. So struct info, and I just do cast type info struct. Right. So this is the struct, and I just do that. All right. Run n and struct info. So what's the stuff we have in there? So does it have a name? There is a name, and it is a table. You can literally check. You can already check that, yeah, if struct info, and it probably has to be inside of the prepare slot, right? So because you need to assert that it is a structure and so on and so forth, but that's beside the point. So name equal to table, right? So if it is equal to table, it doesn't tell you from which module it is coming from or whatever. So there is 9 members. We can like check for the members and stuff like that. Is it possible to get the parameters? So there is parameters in here, and there's 0 information about the parameters, even though, yeah, it would be kind of nice to know the type of the value. But the fact that parameters are like empty array, it's kind of sus in my opinion. This is kind of polymorph source struct. Maybe that's what it is, polymorph source struct. Here are the parameters, and I think that's the parameters in here. So I can't really scroll there, but there's 8 of, okay. So the amount of parameters is 6. If you take a look at the hash table, so hash table, is it 6 of them? 1, 2, 3, 4, 5, 6? It's actually 8, right? So isn't it? I think it's actually 8, but so I'm not really sure. Specified parameters. And the parameters are also type info. So maybe I should just go through them. Polymorph source struct. Name. I can't see shit in this mist. Yeah, it's a table. I'm not sure about parameters. So there is 6 parameters in here, but 1, 2, 3, 4, 5. I confused this comma. I should have not counted commas because this comma is a part of the function. There is 6 of them, so here they are. So that's actually kind of cool. Wait a second. Let's maybe iterate through all of these parameters. So I can do for struct info, and then the name is kind of annoying. Polymorph struct, polymorph source struct. Polymorph. Can I open maybe the module where I have all of that stuff? So type info. It was in runtime, wasn't it? Runtime support type info. Yeah, here it is. So it means now I should be able to polymorph source. I'm not really sure where exactly this field is defined, but it should be defined somewhere. Polymorph. So type info struct. It's not, type info struct is not here. Damn, bro. Where is it? Come on, Jesus Christ. Stop asking questions. Okay. It's a preload. It's all over the place. Okay. So polymorph, here it is. So these are unspecified members. Concrete usable at runtime structs will not have this. But if you look at the polymorph side, it will have parameter. Okay. I already figured it out through the debugger. Thank you. So here it is. So where's the typed? So this is what I want to do in here. Parameters. I suppose this is like a... I'm not really sure why there's separation like that, but whatever. Whatever. And then what we can do, can I just like print different names of those things? I should be able to. The type info. Right, so it has a tag and a runtime size. So, and in the table, the only thing I need is a value type. It's the second one. Can I just print their names or something? So polymorph. Yeah. So type info struct. It's another type info struct, and it's a type info struct member. So that's what they are. It's a, okay, so I do have a name. That's the only thing I wanted. Okay, so it name. So I was looking for like how to get the name of this thing. All right. So and I can just print the whole thing like that and like that. So probably need to specify the new lines. Right. So I have to specify the new lines, and now I'm gonna do auto run and. What do we have in here? So why are you complaining? Unable to open file, blah, blah, blah. I'm in the wrong place, right? So I am in fact in the wrong place. I apologize for that. So typed, where is that stuff? Where is that stuff? Okay. This is what I'm talking about. Look at that, value type. That is very cool. But you can't directly just like find that thing, right? You can't directly find that thing. So where did we have that? So default already lost. What kind of JSON stuff we have opened? So the type preload. Yeah, there we go. Okay. So this is the type, and if we take the type of this thing, it is going to be just. Yeah, it's gonna be kind of stupid. I think it's gonna be type, because type is a type in J. It's very difficult to say that. So the type of the value type is going to be type because type is a type. Right, in languages like Haskell, this kind of stuff is called kind, right? So it's a parameter of the type, which is also type itself, is a kind, right, isn't it? But I don't think in J it is the case, right? So and it's kind of difficult to, you know, formulate that terminology. So, and if I take the type, but I can't take the value of it. Can I take the value? All right, it should be known at compile time, right? So since it's a value, that one is difficult actually. How do I get this type? But maybe it's fine. So it's gonna be value. So if I take it this one, so value type. What I'm specifically looking for, right? I'm specifically looking for name, which is a value type, right? So I found that this is a struct table. Okay, I'm iterating each individual thing, and I found the value type. And as I found the value type, maybe I'm going to put a breakpoint even in here. I'm going to maybe even print all of its internals, right? So maybe that makes sense. Like it and preload. Member type info specified parameters, but maybe like a polymorph has more things. Actually this is parameters and specified parameters. Specified, yeah, these are parameters of polymorph structs that have been specified. And this is probably what we need in here, actually. So these are unspecified parameters, concrete usable at runtime. So okay, and then there is a specified parameters. I need to go into breakpoint back in here, right? And I want to debug this one more time because I want to just see. All right, so didn't really break point, but let's do the following thing. GF2. I think I'm very close. I really think I am very close. So struct info. All right, so here it is. So there are some specified parameters, and I guess this is what we have to look in here. Yeah, we shouldn't go into the polymorph struct. We have to, yes, we have to look into those things. Okay, so that answers my question. So this has to be just specified parameters. Specified parameters and the value type. Yeah, and I just want to look at the value type, which is going to be specified parameters. So this is the struct member. I think type info isn't it. The type info isn't it. It's not going to give me all the information. I need a value. I need an actual value. How do you specify a value? I'm probably missing something. So parameters, these are unspecified parameters, polymorph struct that will have been specified here. But anyway, all right. Okay. Well, I mean, I should have not run it like that. It's auto run. All right. Yeah, it's a value type and it's a pointer, but didn't I explicitly dereference it? I'm pretty sure I explicitly dereferenced it to look inside of it. So type. Ah, well, this is not how we dereference it, forgot. This is how we take the reference. To dereference in Java, you have to do that. Well, it gets a little bit of getting used to, and it is a type. Yeah, so, and it is a type. And it's a bit annoying. So is there something like type info type? Info type. Yeah, so there is no type info. Thank you, John. Very cool. But I don't know. I don't freaking know, because I need a specific type that was specified in there. I need an information about that, which makes it kind of difficult to figure it out. So essentially what I got is I got the type of this thing, but then, well, obviously these parameters, they have values, so those values has to be available somewhere. They have to be available somewhere. Type info struct. I'm sure I'm missing something like very important. I'm sure I'm missing something. Specified parameters, struct member, maybe inside of the. Okay, so type is the type. I don't care, but I do care about the value. So offset into constant storage, and yeah, it has different flags. And this is not what I care about. This is offset in types, but this is a struct member. There's some nodes. Maybe there's something in the nodes. Okay, let me maybe just put a breakpoint in here and just maybe explore it. All right, because as soon as we find this type that was specified as a value, we can just feed it as a value, like as a parameter for parse object as stable, and the feature is completed. That should be, believe it or not, that's just like the feature is completed. We can just go ahead and freaking do that. But anyway, so let's see. Let me try to go into the debugger. I'm gonna run it, I'm gonna step out of this entire thing. And so did it do the thing? Can I take a look at it? And it is a pointer and it's a name. Its name is value type. That's very cool. So it has a type which is a type name offset in bytes -1, which probably indicates that it's a compile time parameter. Very useful. There's some nodes and there's no nodes in here, so that's annoying as hell. That is annoying as hell. So struct info. So that's the struct info. So there's a specified parameters. There's a bunch of members that we don't care about the members. So polymorph so struct. So this is just the parameters, but again, they don't give us the value. There's no values in here anywhere. Constant storage, nodes. There's no nodes. I feel like I can't get that value. Like I don't see where you get the value that you specified in there. Like where do you put it? I don't see it. Should be somewhere. I swear to God if this is not something that already exists. Did they discuss that maybe here? Given JSON. Yeah, so we want to be able to do this kind of stuff. Oh, they already... Okay. With object, number... should give it a try. Slightly related, I've seen parsers the law. Okay, so... Catch-all fields to be created in this case of type JSON, where unknown fields get put. That might be a nifty feature to have here too, as it allows gradual extension more easier. This okay. All right, so they're not really talking about that specific problem. They're not talking about that specific problem. I don't see it honestly. I really don't see it. Specified parameters, because that's the type. Runtime size is 8. So that's the point. Wait. So the type is the type. I can just use it, can't I? If I give it like something bigger, if I say that, well, I mean, it's an integer. Well, it's still 8 bytes. Okay, what if I say it is 3 bytes? How about that? Is it gonna be fine? All right, so we step out of this entire thing. What is it? And it has a type, still 8. So yeah, it's a type of a type, but we can't get the actual values. It feels like these things that you specify here at compile time are not really available at runtime. At least in this whole type info system, I do not see how to get that. So I literally don't see that. One way to circumvent that is maybe specify that through node system, but that's kind of stupid, honestly. Like I should be able to get that information. I should be able to get that information. So maybe we can look for some examples. Specified parameters. Can we do grep or n specified parameters? Are they used? Okay, so we are the only place which is looking into specified parameters. Inside of JI modules, not even JI modules, but JI in general, in how many places specified parameters are actually referenced? So there's changelog. Fix the problem with struct specified parameters not having correct type tags in some cases, which could easily cause crashes. Okay, so that's one problem. Now contains an array specified parameters that tell you what parameters are if this struct was created by filling out parameters from polymorphic struct. The values of the parameter will be in constant storage, just like the constant members will be. Oh shit, it's the... Okay. Wait a second. That is unexpected. And it's array of oh, and it has offset into context. Oh my god, no way, bro. So, oh my god, I got dizzy for it. I didn't expect that. I guess it kind of makes sense. So, it would never fucking occur to me. Why does it make me laugh so much? Okay. At least I know the direction where to look for. Oh man. Okay. So let's fucking go. Oh, that was bizarre. Okay. I get it. That's a funny idea, John. That's a funny idea. All right. So you have a constant storage, right? So you have a constant storage, and there is a 61 bytes in that constant storage. And that constant storage is specifically like preload. It's just like that. Okay, that's understandable. And we found the value, right? So we found the value, and it has a offset in constant storage, which is 8. Okay, and since you know the type, okay, fine, I get it. Jesus, all right. Oh boy, okay. So we get we can check its type, but yeah, so I can just basically assert that type info, what was the, so type is equal to type. That's one assertion that we're making. So that's kind of important. So since we're starting to make assertions, I suppose it makes sense to also do things like info type is equal to struct, right? So it has to be equal to struct. If it is a table, well, I mean, so we can just say that this is going to be the assertions that we're making. So these are all assertions. So that's pretty cool. It's a struct. The name of the struct is table. It has a name value type. So the type of that value is type, and then we have offset into constant store, and the constant store is available info struct. So constant storage, struct info constant storage, right? So this is a constant storage, and I suppose, all right, so we just do that, but after that we have to take a pointer to this thing, I suppose, don't we? But one thing, so it's an array. I can just take the data, add offset, and it gives me the pointer to the bytes, which I can then cast to. I know that it's a type, so that means it's a type info. All right, it's a type info, and that is essentially the value info. That's what it is. That's the value info, and I want to print that value info. So value info, like so. All right, so that should be it. I might as well even frame the whole thing. I wouldn't expect that extracting that is this much work, but maybe it kind of makes sense, right? So because it can be kind of crazy at runtime, so it's just like it puts all of that into constant storage, but maybe it's not finished, right? So maybe that's the problem in here. All right, maybe it's not finished. And yeah, so the pointer goes here. That's understandable. Let's not do the debugging. Let's just do auto run, and it's a pointer, so we have to dereference that pointer. That was not useful. So I'm casting it to type info, right? But is that a good idea to cast it like that, or am I missing something? I don't get it. So change log. Just like a constant members would be. All right. Funny enough, yeah. So we also know its size. Since it's a type, the type of the type, yeah, it doesn't give me info. It's kind of weird. Preload type info. Yeah, so it's a tag and the runtime size. It tells me that the run. Yeah, that was weird. That's what I wasn't sure. The runtime size is 0. The runtime size is 0, which is not correct. That is for sure. So enumeration, so it's garbage. I'm looking at garbage. Enumeration, first of all, is out of the range, right? I didn't realize that. I didn't read properly. And the size is 0, so this is not how you do that, I suppose. And maybe it gives you a pointer into type info, right? Maybe that's what it does, which you then has to kind of dereference twice. All right, so let's give it a try. Okay. John is truly a master of creating puzzles. But I solved it anyway. So let's go. So we got the type, and this is an array of 3 bytes and blah, 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 blah. Okay, cool. So, but the stuff we're going to be supporting, is going to be, it's going to be a pointer. So, which means that it has to be, it has to be specifically an integer, right? So it's going to be allocated like that. Though it's kind of stupid. I suppose the right thing to do would be for, like, primitive types, which are of size of 8, just allow non-pointers, right? Just simply allow non-pointers. But I don't know, it feels like you'll have to hard code a lot of things, right? So if the type is integer, like, support it like that. And, like, just supporting it by value feels like everything should be supported by value, so that means you should be able to do this kind of stuff. But I do not see how to implement that in a light of like hash table, right? Because as far as I can understand, yeah, so you need to polymorph things like table add, which, yeah, so you need to polymorph it at runtime for a very specific key type. So, which is not something you can easily do, I feel like, right? So you just like, you need to dynamically generate like this table add for different kinds of types and whatnot. So I'm not really sure how to, do that. It will be interesting, but okay, let's just implement the thing, as a pointers, right? I think that's gonna be fair. Just as a pointer, so that means this entire thing also has to be like a pointer. All right, so I'm gonna run it, and it's a pointer, and it's a 8, and it's always a pointer, right? Isn't it? So if I do frz set, it is always 8 because that's the size on the machine. Okay, that's cool. And that's the value info, which you're supposed to use to parse objects as a table. So this is the stuff that you're gonna feed into this function, right? That's the stuff. So we're also preparing the slot. And preparing the slot is going to be allocating the table, right? So when we prepare the slot, how do we prepare it? Do we just put it on the heap? Is it just new? So this is the slot, right, or the value slot. Oh yeah, it's on the heap. So there's a value for runtime size. Yeah, alloc. Okay, that makes sense. That makes sense. Okay. So this is a value info. We can do an interesting thing. So, by the way, didn't I? No, yeah, it's fine. So if it's a slot, what do we have to do? We can do the following thing. If this thing is a struct, we're converting it to struct info. Then if the struct name is a table, we're doing that. Then we're going through all of these parameters and maybe value type found, which is initially false, but then in here we say that the value type found is true. There we go. And if we went through all of these things, and by the way, if this thing is a type, we do something like that. We definitely need to break out of this thing. Okay. So we can prepare value slot and value type. So if this is succeeded, if it is generic, we do that, otherwise we do that. And after that, we just skip through all of that stuff. So essentially what I want to do, effectively, is if I get to this point, just do the parsing. If not, try to parse it as something else. All right, so it's a very specific thing. And which means that I probably have to have some sort of a function in here. Right, is type info table. All right, so we're accepting the info, type info, and what we get is a value info, which is a type info, obviously, the value info. So is type info parsable table, and I suppose it should return you OK boolean and the value info that you can then use, like type info pointer. We already use that. So that's basically what we have to do, and this is where we're going to be doing all of that mumbo jumbo. Let me quickly do that. So that's going to be the function, and it makes it super easy to just, you know, unnest a lot of these things. Just simply unnest them. If it is not a structure, return false null. Yeah, so now we can just easily short circuit all of these things. If it is a structure, do that. If it is not equal to the name table, return false null. Okay. Value found, I'm not sure if this is needed, if we're going to be short circuiting all that stuff. Well, it is needed, right? So because at the end, if it was not found, well, we can just at the end short circuit it as well, like so. So basically return false null. We're only gonna return true if we are in here. So if it's a value type, if it's a type, we do that. So here is the value info, and it's, I suppose we also need to kind of expect it to be a pointer. All right, so this is a value info, and if value info type is not equal to the pointer, we return false null. Otherwise, finally, we return true value info. And by the way, since the pointer already indicates a failure or not, so might as well return that specifically, getting rid of all of that stuff. Replace false null. This is null, like that. There's going to be value info, like so. Okay. So. Yeah. What that means is now we can quite easily check things. So this is a parse. If slot is available, we are preparing. Who prepares the slot though? Is there a slot equal, or it might be that the slot, yeah, slot is already prepared for us. We don't have to worry about that. That is cool. That is very, very cool. Value slot and then prepare slot. Does it do anything else? Does it set stuff? It's kind of a weird function, honestly. Kind of weird. I don't like it. I don't like this function. It's kind of a little bit kind of meh. Kind of like puts a lot of constraint in the code. Too much constraint in the code. So if it's a info is a pointer, we convert it into a pointer, and the value info. Okay. It's just like, what kind of constraint is it? It's very abstract, like prepare. What does it even mean, prepare? That's different things for different types. And it's just like, kind of a weird function that is abstract and puts unnecessary constraints on the code. That's my opinion of this function, right? So it's too abstract and just like limits what I can easily do without like revamping the whole branch in here. Like, why do I have to revamp the whole branch? I don't feel like I need to revamp the whole branch. I don't think I need to do that. So yeah, and this puts such a constraint that now you have to pass information to this part of the code through booleans, out of all things. Oh boy. Okay, so okay, I need to integrate some stuff into this function. Right, so expected type abstract, but if it is a pointer, you take a value it's pointing to, right? But if it's a pointer to pointer, it's kind of bizarre. So an expected type, okay. So, and also there is a is generic, right? Is generic JSON value, and okay, where is it? So it just checks that if it's a type info of that. Okay, it's fine. It's fine. If it is generic, not generic, and value type is not equal expected type, you just throw an error. Okay. I have a feeling that I have to add another boolean in here, right? Is generic is table, and it's like, why do I have to do, like, you see, this is such a, it's not a great function because it forces you propagate this much information out of it through all these stupid flags. But I don't have time to refactor all of this stuff, and I don't want to refactor all of this stuff. I don't think it's needed. So yeah, and because of that table, we can grab all of that stuff in here. And now, since I need to propagate all of that information out of this function, every single place that calls this function needs to be modified accordingly in here. Yeah, it's not a great. Okay. Okay, so this is gonna be that. And I suppose to not break all of these places, we have to add that stuff in here somewhere. That's what I'm thinking. Okay, so something like that. So with type info, I can probably use it like that. Oh boy. Okay. So value info is type info parsable. So, and so the value info is already taken. Bro, the value info is already taken. Okay. Value info member. I hate this function. Why is it designed like this? Okay. Member info. If member info is a thing, what we have to do, we have to just return things. Okay. Okay, so what was the prepare slot? It returns a slot, right? Yeah, it returns a slot, whatever. So this is a slot. It was successful. It is not generic. If it is a table, it is not generic. Type info that we're returning in here is actually member info, and it is a table. It is true, right? So I guess that's how I'm gonna be doing that. It's kind of stupid, but I mean, it's a hack, right? In all of these places, obviously, it has to be false now. In all of every single place where we do all of that stuff, it has to be false now. Is type blah 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 blah. What are they saying? Attempt to dereference. Well, I mean, yeah. So we probably have to now dereference it like this. I'm not sure if I have to wrap it in parentheses. What's the precedence of this entire stuff? I'm not sure. Value info type info pointer. And cast it to type info pointer. We know that it is a pointer. Alright, so returning this has to be false, and this has to be false as well. Okay. So now we have to go to the places where we are looking for the stuff. Okay. So is generic, where is this function defined even? Okay. Is table. Is stable, otherwise if is table, parse object as table. I can't believe I have to write such code, but I mean, fine. So we have to do this is remainder slot value slot. Is it a value slot? Yes, it is a value slot. Value info. Yes, it is a value info. Ignore unknown. I guess we're just propagating all of that stuff. Rename. Oof. I have to cast it to, well, I mean, I'll let the compiler tell me. And this is a float handling float. And it gives us the reminder and the success. Remainder and success. Sorry, I don't speak English. If it is stable, we'll just do that. Okay, compiler, tell me what's wrong. Yeah, I knew that. So it has to be cast type info pointer. It must be type info pointer. To parse slot. Yes. And I'm using member info as the thing. Okay, still doesn't work exactly. Declaration of 2 parameters, member info. What am I looking at? Excuse me. Fuck. Wait, didn't it work before? What happened? Member info all of a sudden. Is that because of this thing? Okay. No. What? Why all of a sudden this place broke? Bro, what happened? Okay, so let me read it one more time. I don't get it. So the declaration of this of argument 2 requires a value bake. It is declared with 2. Okay. Why does it require value bake out of all things? What? Am I going crazy or what is going on? Excuse me. It's a run. I'm allocating this shit at runtime. What are you even talking about? Ah, wait, but how did it work before then? Okay, so first comes this and then that. Did I swap it around accidentally? Yeah, I feel like maybe I swapped it around. Okay, so what are you saying? A remainder. Okay. Procedure did not match any of the overloads. Typed member slot. But does it give me... Oh god, it gives me the... Alright, so I have to do something like this, I suppose? Table, not enough wanted. Okay. Table at key. So I suppose, since this function was never really like polymorphed or called, it was never really compiled. So that's... Oh, is that how Java works? Right, so the function, I never called this function, so it just syntactically checked it, but semantically it didn't do any type checking. I think I vaguely remember Java doing that. That's kind of weird, but I mean, whatever. Okay, so let's fucking go. And it compiles, and if I try to run the whole thing, I think it fucking worked. Holy shit. Does it have 69? Well, I mean, yeah, whatever. Can we now go to main.java, and just iterate JSON, because the tables are iterable, you can iterate them, and then we're gonna print the value, the key, which is it index, that's the key, and then the value, and we have to dereference that value, obviously, because it's a pointer. Right. Fascinating, but okay. So one thing, I suppose I know what's going on in here. Well, first of all, this is not how you dereference things. That's first thing. Another thing is, if we're going to be doing the key, all right, if we're going to be setting the key, we probably have to copy the string. And that's one thing we'll have to do. Absolute buzzozing, motherfuckers! I did it! I fucking did it! Holy shit, that was hard! Oh. Anyways. Okay, let's try to parse the, FFZ itself. So we're reading this thing, and we're going to be parsing it specifically as FFZ response, right? Which contains the table, which is a pointer to FFZ set. Let's see. So we're not going to be iterating that, but it's just like, okay, at least it works, right? We can try to print the whole thing, but I feel like it's not going to tell us that much, right? I don't think it's going to tell us that much. At least it's not entirely empty. All right, so one thing we can do, we can specifically print default sets, right? So that's the array of integers. That's the thing. And then we can do, I don't know, JSON sets. This is going to be a new line, and I'm going to be iterating JSON. I don't want to call it JSON also. Let's call it response. Response sets, right? And in here we're going to be doing something like, so it has a bunch of emoticons. We can try to print them, but maybe not. Okay. This is going to be that, and so it index, right? So you have a it index, and the value is going to be the amount of emoticons you have in there, right? It's going to be it emoticons count. That's the idea. That's the idea in here. Okay, so that's the interesting thing, is that that's exactly why this API is the way it is, right? Because the sets contain some stuff which is not in the default sets, but we have to ignore everything that is not in the default sets. So I guess we managed to do that. Well, we can try to print the sets themselves. Right, so yeah, let's just like not do count and let's see what it's gonna look like. Yeah, there you go. Here are the sets, the IDs and the names of the emotes. We successfully added support for the table. So, but there is still a few things that I would love to maybe iron out. Yeah, I'm not sure if I want to submit this support as is, because this support is rather limited, and I honestly have no idea how to get rid of this limitation that the value has to be a pointer. Like, I don't see how to get rid of this limitation, because like forcing the user to have their tables to be something like string and like integer and pointer to integer is kind of stupid. Like, at least you want to have some sort of exceptions for primitive types, or maybe some exceptions for strings, right? Because strings are kind of already pointers because they're slices of bytes, which means that just generally slices should be also be kind of by the pointer because they're effectively fat pointers anyway. Right, so as you can see, there's like lots of different exceptions that you probably want to add in here. And that's, I don't know how much time it will take to add support for that. So my idea is going to be the following. It's that I'm going to use my extension locally for my needs. And I'm going to propose that to Raphael, and we can maybe discuss that in a pull request, like how to bypass this limitation and stuff like that. So I guess that's how I'm going to go with this contribution. All right, I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all on the next recreational program session with Mr. Azuzin. I love you all.